Okay, task 3. Task 3, the data is, actually this is all the data. What this data is all about. Okay, every year, the Hong Kong government will issue the financial statement, and then every year they will do the estimated surplus of the government. And then at the same time, they will report the actual surplus of the previous year. So, such estimation is done by the financial secretary of the Hong Kong government. So, as you can see, the estimated surplus and the actual surplus deviate a lot. So, for example, for this one, the deviation is over 1,000 billion Hong Kong dollar, which is outrageous. And so, the first question is to create a linear regression model to predict the actual surplus based on the estimated surplus. So our first step actually is to copy the data into Excel. And then I will explain what is the regression model. Okay, after you paste it, the data should look like this. You don't need to worry about the financial years. If it displays like this, which is okay, you can just leave it here because we will not touch the financial year data. So, last week we have done the correlation, right? We can study the correlation between the estimated surplus and the actual surplus, right? And it will give you the correlation coefficient, like 0.5, and then you can determine whether such correlation is strong or not strong, right? But the correlation coefficient can only tell you the strength of the association between the estimated surplus and the actual surplus. It tells you absolutely nothing about how to predict the estimated surplus, how to predict the actual surplus with the estimated surplus. So for this application, we will use the linear regression model to do that. And a linear regression model is like this. And another way to write it is something like this, but it is actually not that important. So we can plot the data as a scatter plot, right? So this is the estimated surplus, and that one is the actual surplus. And then for each data point, which is the each pair of data on that table, right? And we can plot it like this, right? Actually, it should be some data here because sometimes the estimated surplus can be negative. Right? Up to this point, still okay, right? Just the scatter plot. And with this data, we can free a straight line with the data. so that we can estimate the trend of the association. And on any straight line on a Cartesian plane can be expressed as something like this, which is called a point slope form. What's that? Okay. We can express any straight line on a Cartesian plane with only the slope and a point, which is the y-intercept. You should have learned this in the high school math, right? Yeah. And what we are trying to do, okay, as you can see, these two are actually very similar. And we need to estimate the beta 1 and the beta 0 of this line, which is actually just the point slope form. So this one, beta 1 is the slope, and the beta 0 is the y-intercept. And the epsilon actually meaning error. Okay, for example, this line, and then we have the difference between the line, the values predicted by the line and the actual number. So that one is the epsilon, which is something you cannot predict. So we can use an alternative form like this, which is het y meaning predicted y, equal to beta 1 x plus beta 0. And after we have the values of beta 1 and beta 0, we can do the prediction of the predicted y using x. Okay, for example, we know that the estimated surface is these values, and then we can refer back to the line, and then we can get the estimated y. Okay. So what we need to do is to find the beta 1 and the beta 0. And in my high school mathematics, we do it by hand, meaning we will plot the dots on a graph paper and then use a ruler to move that up and down and then draw a straight line, right? But now we have the computer, so we can do it by the computer. So actually it's very straightforward. Okay, we have the data here. And the estimated surface, as the question dictated, the estimated surface is your x, and the actual surface is your y. So we can change it to x, and then that one to y. And then we need to find the beta 1 and the beta 0, meaning the slope and the intercept. And in the cheat code, it actually tells you how to find the intercept and the slope of a linear regression line. So it's actually very straightforward. For the slope, the function is called slope, okay, which is intuitive enough. So the slope, or the beta 1, is equal to slope. And the slope function have two arguments. One is the ln y, so we can just feed in all the y into that function. And then ln x, so again, ln x. So, and then close it, and then we get the slope. Okay, the next step is the beta 0, which is the intercept. So beta 0 the function is called the intercept. Again, long y, all the y, and long x, all the x, and you should get something like this. Okay, now we get the two values, which is the predicted y is equal to 1.009798 x plus 3.9394. Okay, this is the linear regression model we created. And so that one is the y-intercept. So it's actually meaning that this is a definition of y-intercept, right? So the height of the crossing point between the regression line and the y-axis is this point is actually equal to 0.33 line. Therefore, if the estimated surface equal to 0, the predicted y should be equal to 39.4 million. Okay, this is the interpretation of the intercept. Okay. And then the slope. Suppose that one is 100, and this one is 101. So the estimated surface increases by 1. Okay. So the slope actually is saying that okay, when the x increases by the 1 unit, y will be increased by that number of units. So that one will be 1.0098. That is the interpretation of the slope. Okay, you should know that because the question asks you about it. Okay. Once again, the intercept is when the x equal to 0, what is the values of predicted y? And the slope is the unit increase in the y when the x increases by 1 unit. Okay. Any questions so far? This should be straightforward, right? But
the last one, like the slope and the intercept and the rest, another.
okay, the epsilon, right? That one. This one is something we cannot control and something we cannot estimate. That one is called the error term. Okay, what is the error term? Error term is when you have a line, right? And when you have a data point, okay? And then you make an estimation of that, make a prediction of that point. For example, you know that the x is equal to 200. for this point, and then you want to estimate the values of x, right? And when you use the regression model to do the estimation, right, it should be equal to 200 times 1.0098 plus 339.4. That is the estimation. This is the prediction, right? And the error term is equal to the actual y minus the predicted y. This is something you cannot control, so you can just ignore it, okay? Now, we have the data, the values of a slope and the intercept, right? So, question 2 is to do the prediction based on these two values. So, suppose the financial secretary estimate the government surplus for this financial year to be negative 34. And based on the regression model we develop, what is the anticipated actual surplus? So, we know that y, or the head y, equal to the slope times x plus the intercept. So we can just plug in the values of x into this equation, and then we will get back the head y. So we know that the x provided by the question is equal to minus 34. So which is equal to, and then the head y. The head y is equal to the slope times x plus the intercept. So which is equal to 305 or 1 something. So that is the anticipated actual surplus when the financial secretary estimated the surplus to be minus 34, and then the actual surplus should be 305. You can see that the difference is quite large. So actually our financial secretary is not doing a good job in doing the estimation. So with this knowledge, how to create a regression model, and you can be rich because you can make prediction of the Hang Seng index, based on the previous day, and then you can estimate the Hang Seng index of the next day by creating a regression model like this. And you can try. Yeah, that is the end of the questions 3, task 3. So, questions? It's straightforward if you know what is going on. But if there is no question, then we will move on to task 1 and then task 2. No question, right? If you have questions, you can email me or anything. But anyway, I will stop the recording for now.